mask as we proceed. Subnetting a subnet, which we also refer to as Variable Length Subnet Mask. In our last class, we did subnetting, trying to learn how to manage IP addresses. But if you take a look at what we did critically, we were still wasting some IP addresses, even though I said it is good to give room for growth. That's okay for public IP, for private IP address. But if you are using a public IP address, you cannot afford to waste even one IP address. You cannot afford to waste even one IP address. And that is why we are going this direction in today's class. We want to see if it is possible not to waste any IP address at all and still do our subnetting. That is going to take us on a long journey. So I'm going to give us just two examples, then I'll give room for questions. So example number one, let's assume I have this requirement. At least I'm sure you know what I'm doing right now. I want to give contracts to Pedro now to go and execute for me. And I've given him 192.168.1.0/24. And then I told him that there are 4 subnets, 4 networks needed. So I can tell you that this place, one of the network, let's call it admin, they are in need of 30 IP addresses. Let's say another segment or another department, let's say accounts department, they are in need of, let's say 12 IP addresses. Then another department, let's say HR, they are in need of, let's say, I'm doing calculation in my head. Raised to power 3, power 530, raised to power 416. Let me make this one 14, and then this one 6, and then this one 2. So let's call this one, let's say manager. Oh, what have you come anything? So look at the needs on the screen right now. Admin is in need of 30 IP addresses. Account department is in need of 14 IP addresses. HR, they are in need of 6 IP addresses. Managers are in need of 2 IP addresses. And you were given the same network we worked with in our last class, address to work with. I know what you guys will do. You will do what we did in our last class. You will just subnet based on the 30. That's the highest need, and you allocate. So whenever you have a scenario like this, you have to look for the network that is in need of the highest number of IP addresses. In this scenario now, it is only admin. It is admin that is in need of 30 IP addresses. So we have to go first of all subnet based on that need. So the way we are going to go about this now, we're going to be thinking about the IP address needed, the highest need, and of course the numbers of subnets, back to what we did in our last class. I want to be able to take care of 4 networks. But because I know about VLSM, I can decide not to bother about those networks because I'm going to handle those ones later. Just watch and see what I'm going to do. I will connect the dot later. So just subnet based on the first need first. First need, which is 30 IP addresses is needed in admin block. Of course, we need 4 subnets, but let's just be sure that we have a need of 30 IP address. So in this scenario, watch out what I'm going to do, guys. So my IP address again, 192.168.1.0. Subnet match is 255.255.255.0. Convert this down to binary. 1, 2, 3, 4, 5, 6, 7, 8. Guys, our attention is to the right now, not to the left. What do I mean by to the right? The right part is the one that gives us the number of addresses per subnet. The right side, the remaining numbers of bits on the right, is the one that gives us the number of addresses per subnet. So now you are not going to start doing the permutation in your head. If I borrow 1 bit, apply the formula, 2 raised to power 1, that will create 2 subnets. I have 7 left, 2 raised to power 7, that will be 128. No, I don't need that. I'm going to be wasting too much. What if I borrow 2 bits? You apply the formula, 2 raised to power 2, it will create 4 subnets. I will have 6 0 left. So 2 raised to the power 6, that will give me 64. 64 is too much. I want to take care of 30 addresses. What if I borrow 3 bits? Okay, 2 raised to the power 3 will give me 8 subnets. How many bits do I have left on the right? 5 bits. 2 raised to the power 5 will give me 32. I'm in need of 30, but I'm going to get 32 if I borrow 3 bits. Can I still borrow? Let's try. What if I borrow 4 bits? 2 raised to the power 4 will create 16 subnets, and we have 4 zeros left on the right. 2 raised to the power 0, 16. That would be 16 addresses per subnet. This cannot take care of what I'm looking for. So the best I can do is to borrow 3 bits and create 32 addresses per subnet. I am just particular about this subnet for now. I need to be able to take care of this and not waste any IP address. Forget about the total number of subnets. That will be taken care of later. So when you are doing what we want to do right now, because you know this, you are particular about the addresses. The subnets will be sorted later as we go, continue in this journey. So you do your permutation, you go left, you go right, you go right, you go left, you go left, you go right, you go right, you go left, and do your permutation and see that, okay, guys, if I borrow 3 bits, this will solve my problem. So we are more concerned, we are particular about the addresses. We don't want to waste any. And sometimes we don't have a choice. We're going to waste 1 or 2 sometimes. Okay? So now, based on what I have on the screen right now, that means I can decide to borrow 3 bits. So let's try to borrow 3 bits. Let's try to borrow 3 bits. So I'm going to give room for question after this, guys, because I don't want to just be talking and then assume that you people are familiar with me, and then there are issues that need to be sorted. So I'll give room for question. So now I'll write out 1, 2, 3, 4, 5, 6, 7, 8. I'm going to borrow 3 bits. How did I arrive at that? I've done my permutation, left and right, right and left. 2 raised to the power 3 will give me 8. 2 raised to the power 5. We did this in our last class. Will give me 32 addresses. That's the best I can do. Then guys, write out the subnet. Subnet 0, subnet 1, subnet 2, subnet 3, subnet 4, subnet 5, subnet 6, subnet 7. So for subnet 0, since there are 32 addresses per subnet, the range of the address will be 0 to 31. Don't forget that. The next one will be 32 to 63. The next one will be 64 to 95. The next one will be 96 to 127. The next one will be 128 to 159. The next one will be 160 to 191. The next one will be 192 to 223. And the last one will be 224 to 255. Guys, these are our 8 subnets that we got. So we're going to carry the first subnet address and allocate to admin. So we're going to say, admin, guys, you are going to be given admin. You will be given 192.168.1.0 slash, of course, you know that slash 27. We have allocated this. It cannot be allocated again. What I taught you guys in the last class, you will have carried the second subnet, allocate to account, carry the third subnet, allocate to HR, carry the fourth one, allocate to manager. But look at it, account people are in need of 14 IP addresses. Each of these subnets can give you 32. We're going to be wasting 18. HR is in need of 6. This network can give us 32. We'll be wasting 20. That should be 26. Managers are in need of 2 IP addresses. If we give 32, we'll be wasting 30. So is there a way we can deal with this and not waste any IP address? That is why we are here today in this class. So the question now is, okay, which network is the next network? Subnet 1. Write out the IP address of subnet 1. Let's see what we can do with that. Let's see if we can re-subnet it. So, guys, don't forget, we still have all of this. We may use them, we may not use them now. If we don't use them now, they will be used in the future. But let's write out this address, this network address, and see what we can do with it. So I'm going to be dealing with that IP address now. 192.168.1.32/24. That is the one we want to deal with now. Should we assign it to account? No. Why? We'll be wasting addresses. Can it be resubnetted? That's what we want to find out. That is the essence of this class. So I'm going to write that address out now, guys. Subnet 1 is, don't forget we have killed this one now. We've gotten rid of this. 192.168.1.32/27. This is our subnet 1. Should we assign it to account department? We will be wasting addresses. Can we resubnet it? Let's find out. When we say can we resubnet it, can we break this network address into 2 or this subnet address into 2, and we'll still be able to take care of accounts and not waste any IP address? So whenever, take note now, whenever you want to resubnet an address that has been subnetted, you need to be very careful. What is my new subnet mask? 255.255.255.224. That's the meaning of /27. We did that in our last class. If you now want to write out the remaining bits, 1, 2, 3, 4, 5. What happened to the 3 bits? The first 3 bits, we borrowed it. That's how we landed here. So we have only bits left to work with this new subnet. So whenever you're working with a subnetted address, you deal with the remaining bits, not the whole 8 bits. Whenever you're working with a subnetted address, you deal with the remaining bits. So we have only 5 bits left in this scenario right now. So this bit that is left here now, is there a possibility of resubnetting this network subnet address? So I'm going to now crack my brain. If I borrow 1 bit and apply the formula, it will create 2 subnets. The remaining bit that is left, apply the formula, 2 raised to the power 4, it will be 16. And we are in need of 14. We will be wasting 2. What if I borrow 2 bits to create 2 subnets from this subnet? I will create 4 subnets and 8 addresses per subnet. That will not be enough. So I don't have a choice now. The only thing I can do right now is to borrow 1 bit here. And this will give me a network of 16 addresses, or 2 networks of 16 addresses. So that means I can borrow 1 bit. If I borrow 1 bit now, I will have 2 subnets. Where are the subnets? Subnet 0 again, because this is a subnetted address, and subnet 1. Subnet 0 and subnet 1. So subnet 0 will have its own addresses. Subnet 1 will have its own addresses. So now we know that there are 16 addresses altogether. Now take note now, this is where people make mistake. When we were doing the others, we were always starting from 0 to, but the address we are dealing with right now starts from 32. So we're going to say 32 to, since we know that there are 16 addresses, it will have been 0 to 15, 16 to 31, and so on and so forth. But the address we are dealing with will start from 32. So that will be 32 to 47. You add 15. The next one will be 48 to, that will be 63. And guess what? We're done. What do I mean? There are 2 subnets gotten now. The first one is 192.168.1.32. How is this .32 different from the .32 on the other side here? We borrowed 1 more bit. This one is going to be /28. And then the next subnet gotten is 192.168.1.48/28. Ladies and gentlemen, I can carry this one right now and assign it to account department. What did I do? I resubnetted a subnetted address, or let me say, I subnetted a subnetted address. That address we're dealing with is not a default IP address or network address. It is an address that has been subnetted before. Now I am resubnetting it so that I don't waste IP address. In resubnetting it, I got 2 subnets out of it. Now I have allocated 1 to accounting department. Now I have 1 left. Can I assign this one left to HR? We'll find out. Can it be resubnetted? we'll think about it. So you see how we are managing this IP address. This is just subnet 1. We've not touched subnet 2. We've not touched 3, 4, 5, 6, 7. This is just subnet 1 we are resubnetting. And we still have another subnet out of it right now. So now we have 192.168.1.48/28 left. So I've assigned this to account department. So this is gone. What about this? Can I assign it to HR? Let's find out. Let's write it out and see what we can do with it. .148/28. Okay, guys, let's see. .192.168.1.48/28 is one of the subnets that we have from another subnet. So we'll assign this to HR. This address can give us a total of how many bits is that now? Raised to power 14 addresses. A total of 14 addresses. 16 actually. 16 addresses. If we assign it to HR, we'll be wasting 10 IP addresses. Is there a possibility of resubnetting this? You do your calculation again. So the new subnet mask got in here now will be 255.255.255.240. And the remaining bit is 1, 2, 3, 4. Because we have already borrowed 4 bits altogether. We're only left with 4 bits. So as it is right now, you look at this. If I borrow 1 bit, will I be able to take care of HR? They are in need of 6 IP addresses. If I borrow 1 bit, 2 raised to power 1, that means I can break this subnet again into 2. 2 raised to power 1 will create 2 subnets. Then the remaining bits, 2 raised to power 3 will give me 8 addresses per subnet. And I'm looking for 6. Yeah, this is subnettable now. We can resubnet this. I will go ahead and resubnet this. So I'm going to get 2 subnets, 8 addresses per subnet. I will write out the subnet again. Subnet 0, subnet 1. What will be the range of the address here? Don't forget, we are starting from .48. That is the address we are dealing with, the subnet we are dealing with. That will be 48 to, if you are going to get confused, you know you are dealing with, everything should have been, it's be 8 altogether. If you started from 0, it should have been 0 to 7. So since I'm starting from 48, just add 7. 48 to plus 7, that will give me 55. The next one will be 56 to add the 7 again. That will give me 63. These are 2 subnets gotten out. So I will write out the first one, which is 192.168.1.48. Guys, this time around again, we have borrowed 1 more bit. This is going to be /29. And we have 192.168.1.56/29. I will carry this network address and assign this to HR department. I have another one left that I can decide to give to manager if it cannot be resubnetted. But we're going to find out if it can be resubnetted or not. So you see, I am moving gradually, managing just 1 subnet from a major network that I got, and I'm resubnetting and resubnetting them. Subnetting and resubnetting and resubnetting them. So now I've assigned .1.48. Look at it. I've assigned for .48. I am left with 1.56. I will not think again. Can I assign this .156 to manager's department? I'm going to waste 6 IP addresses because they are in need of 2. Can it be resubnetted again? I will try to find out. This is just an example I gave you guys. So sometimes you have to borrow 2 bits to take care of in order for you not to waste IP addresses. My example just happened to be 111 bit. So I can write that one down. 192.168.1. What's that address? 56/29. If I assign this right now, I will be wasting 6 IP addresses. So now the question is, can I resubnet this again? Let's find out. I'll write the new subnet mask out. 255.255.255. This should be 248. You do your calculation. I've taught you how to do that. We have how many bits left? Only 3 bits. 1, 2, 3. Because this is /29. In order to make this 32, because all our bits 32, we have only 3 bits left. So you look at this IP address and I re-subnet this. If I borrow 1 bit, put my formula, 2 raised to the power 1, I have 2 bits left, 2 raised to the power 2 will give me 4, then 2 subnet. That's nice. These people are in need of 2, and I can give them, I have 4 IP addresses from me, and I can have 2 subnets. I will break this into 2 again. So subnets will be created from this. I will have subnet 0, I'll have subnet 1. Then subnet 0 will be, this is supposed to be 0 to 3. Then we're not starting from 0. The address we're dealing with is 56. That will be 56 to 59. The next address will be 60 to 63. So where are the addresses that I've gotten now? 192.168.1.56/ don't forget, we borrow 1 more bit, 30. Then we'll have 192.168.1.60/30. I will carry this subnet here and give to manager's department. What happened to this last one here? I will keep it and document it for the future. With the other IP addresses, those other IP addresses that we didn't use when we started this journey, they will all be documented for the future. Meaning, if the network grows again, we have IP subnets that we have not used. This is how people that work with service providers manage public IP addresses. This is how they manage public IP addresses, step by step. They keep on re-subnetting until they can no longer subnet. This is called VLSM. Why is it called VLSM, guys? Let me tell you. Like this side here, we have /24. The IP address we give here, we have /20, actually /24, 27 rather. This one we have /28. This one IP address here we have /29. The IP address here we have /30. You will see that the subnet masks are not the same everywhere. That's why it's called variable length. They have different prefixes. They are not the same like what we did in our last class, where everybody is /27, they are all /27. If they are all /28, they are all /28. But once they have different slash, that is why it is called variable lengths. Variable lengths subnet mask. Variable length subnet mask, VLSM. When you begin to resubnet an address that has been subnetted before, you land with this kind of design, and this is what is obtainable everywhere in the world, especially when you're dealing with public IP address. For private, we can afford to waste, no problem. But for public IP addresses, you cannot afford to waste IP addresses. This is our VLSM. Now, I don't like mixing this up with what I taught you guys in the last class. It's not something that is going to be long, but I want you to be in, when your brain is fresh, you come and hear this one afresh, and so that you can be able to digest this. So that is that and that. Let me give room for. So look at, I just did that now. I forgot to continue the recording. Thank you, Mr. Isaac. Thank you. So I already forgot. So look at, this is LAN E. LAN E. And you were given 192.168.1.0/24 to use to take care of all of these needs. So anytime you have a scenario like this, you must think about the one with the highest need first, which is 60. So just like what we've been doing, write out the address 192.168.1.0. Then write out the subnet mask 255.255.255.0. We are subnetting from our host portion 1, 2, 3, 4, 5, 6, 7, 8. And the question is this: I am particular about the right side, because I know I'm going to resubnet addresses later, so I don't bloody care about the subnet part. I need 4 subnets. I need to be able to create borrow 2 bits. So when I say I'm particular about the right side, I mean what is left on the right. That's my concern now. I want to be able to take care of a network of 60 IP addresses without wasting any, if possible. So I will do my permutation. If I borrow 1 bit, I will put my formula So if I borrow 1 bit, 2 raised to power 1 is 2. The leftover is 7. 2 raised to power 7 is 128. What if I borrow 2 bits? That will create 4 subnets. What is left on the right? 5, right? No, 6, sorry. 6. 2 raised to power 6. 2 raised to power 6 will give me 64. It's more than what I'm looking for. I'm looking for 60. What if I borrow 3 bits? 3 bits, if I put my distance, 2 raised to power 3 will be 8. The leftover will be 2 raised to power 5. And this will create 32 addresses per subnet. I cannot take care of a network of 60. So I don't have a choice. I have to stay with 2. So if I borrow 2 bits, 2 raised to power 2 will give me 4 subnets. And the leftover 2 raised to power 6 will give me 64. So I'm in need of 60 IP addresses. If I borrow 2 bits, it will create a network 4 subnets with 64 IP addresses. I will wait for. There's nothing I can do again. I will just have to borrow 2 bits. So it's confirmed that I will borrow 2 bits. So watch out and follow me right now. So I will get rid of this mess I created on the screen, and then create and borrow and write out all those bits and borrow 2 bits. So watch what is going to happen, guys. So if I borrow 2 bits, so 1, 2, 3, 4, 5, 6, 7, 8. If I borrow 2 bits, put the formula 2 raised to power 1 will create 2 subnets. The leftover one call, 4 subnets rather. The leftover 2 raised to power 6, 64. Meaning if I borrow 2 bits, I will create 4 subnets, and there will be 1, 2, 3, 4, 5, 6, 64 addresses per subnet. 4 subnets, 64 addresses per subnet. And now the next thing is to write out the subnet's address ID. So the first subnet will be subnet 0. The second subnet will be subnet 1. The next subnet will be subnet 2. The last subnet will be subnet 3. And in this subnet 0, what will be the range of the addresses? Don't ever forget, there are 64 addresses altogether. So if you were to put it in range, that will be 0 to 63, because 0 also is part of the number. I said that in the last class, so don't forget that, guys. So my first subnet will be 0 to 63. The next subnet will be 64 to 127. 64 to 127. The next subnet will be 128 to, then you had 63 again, that will be 191. And the last subnet will be 192 to 255. These are all the 4 subnets. So where are the network addresses of each of these subnets? All the numbers on the left, they are the network addresses. What about the broadcast addresses? All the numbers on the right, they are the broadcast addresses. So I can write them out. So for subnet 0, the network address is 192.168.1.0. Now the slash will be what? We borrow 2 bits, guys. To add this to the old subnet mask, we have killed this. We are going to get slash 26. This will be slash 26. The subnet 1 network address will be 192.168.1. Look at it here, 64/26. The next one will be, that is subnet 2 now, 192.168.1.128/26. The last one will be 192.168.1. Look at it here, .192/20. These are the network addresses of each of the subnets. What about the broadcast addresses? All the ones on the right. What about the usables addresses? All the ones in between. This shouldn't be any big deal. We did this in the last class. This is the first stage in subnetting. I've not gone to re-subnetting now. So now let's assume you don't know about subnetting a subnet. You don't know about VLSM. You know what you will have done? You will carry subnet 0. Okay, we have 4 subnets here. It's not enough. Let's assume it's even 4 subnets we needed there. You will have just carried subnet 0, assigned to 1, subnet 1, assigned to another, subnet 2, assigned to another, subnet 3, and then you are done. But because we know that we can re-subnet, we don't care. We're going to get to meet the needs of the users of the network later on. I will carry these 4 subnets here. That's the network address assigned to LAN A, and say LAN A, this is your network address. I have assigned this subnet 0. What happened to subnet 1? Should I carry and give LAN B? LAN B is in need of 30 IP addresses. I will be wasting 34 IP addresses, because that's 64 minus 30. I'll be wasting 34. Class rep said I didn't separate. This is the separation. The numbers on the left are the network addresses. The numbers on the right are the broadcast addresses. The one in between are the host addresses. Even when we re-subnet, it's the same concept. So now, this address here, this subnet 1 here, I don't want to give it to LAN B. Now the question is, can I re-subnet it? I will have to find out. Let's clean up and see. .1.64. We don't want to allocate it. We want to see if we can re-subnet it. If it will be able to meet our needs, and we'll be able to still get more subnet out of it. We don't want to waste any address. We want to see. That is .64 right here. Let me get rid of everything here. We've allocated one already. Let's see what we got. So we have another subnet. We want to see what we can get, what we can do with it. So the subnet we're talking about right now is 192.168.1.64. Don't forget, this is /26. What is the meaning of /26? 255.255.255 dots. That will be 128 plus 64. Because we borrow 2 bits, we turn them to 1. I taught you guys how to calculate the new subnet mask. 1, 2, 3, 4, 5, 6. By the time you convert this to decimal, it's going to give you 192 plus 64. That to be .192. This is the meaning of /26. So right now, this address that is here right now, we have borrowed 2 bits already, guys. How many bits do we have left? 6. If you want to re-subnet this address, you are going to be dealing with only 6 bits. 2 bits are dead already. They are gone forever. So I will write out the 6 bits. 1, 2, 3, 4, 5, 6. Now, with this 6 bits now, I need a network. I need a network that can take care of 30 IP addresses. Can I do something here? Let's think about it. Let's say, okay, if I borrow 1 bit, throws power 1, we create 2 subnets. I have 5 bits left. Throws power 5, will give me 32 addresses per subnet. Yeah, this will work, but I'm going to waste 2. What if I borrow 2 bits? I will not get up to what I need. Then I now realize that I can borrow 1 bit. Meaning, out of this one subnet, I'm creating 2 different subnets. Out of this one subnet, I want to create 2 different subnets because I don't want to waste any IP address. So I'm going to have 2 networks. And each of the network or sub-networks will have their own addresses. So I will create 2 subnets out of this. And that will be subnet 0 again, and then subnet 1. Now, don't forget, the network I'm creating now, altogether I will have 32 addresses. But we are not starting from 32. The network we are dealing with is starting from 64. If it starts from 0, then you will have done 0 to 31. But now this one does not start from 0. So that will be 64 to, you do the addition now, 95. How did I get 95? 0 to 31, what's the difference between the two? 32. 64 to 95, what's the difference between the two? 32. Then the next address will be 96 to, then you have 31 again. That's my own method. So if you have 31, the next one will be 127. Now I've gotten 2 networks out. That will be 192.168.1.4/ we have borrowed 1 more bit. That will take this into /27. The second subnet will be 192. Don't forget, all these numbers on the left are the network addresses. The ones on the right are the broadcast addresses. 192.168.1.96/27. I will carry this subnet assigned to LAN B. 192.168.1.64/27. I have taken care of LAN B, and I still have extra subnet left. .96. I have .96 left /27. Can I resubnet this? We're going to find out, because the next network is in need of 14 IP addresses. So let me ask class rep first if I'm communicating before I travel far. Yes, class rep, can you talk to me? Are you flowing with me now? Is it getting clearer? Oh, okay, beautiful.
Yes, please. I'm enjoying it now.
Okay, okay. So now, let's continue, guys. We'll soon be done with this part again. So now, I have allocated this .64/27, this one here. I've allocated it to LAN B. I have this one left. Don't forget, we have not touched the main subnet we started with. We only pick subnet 0 off, that main one. We still have subnet 1, 2, and 3. We've not touched those ones. We are just managing, it's like what we got now. I will write out this address again, .1.96/27. Let's see if I can manage this again to take care of my needs. Let's find out. .1.96/27. So can we manage that again? Let's find out. Let's find out, guys. Let's find out. Okay, so write out the address again. 192.1, sorry, .168.1.96, right? /27. If we assign this to LAN C, this address can give us 32 IP addresses. If we assign it to LAN C, we will be wasting 18 IP addresses. Is there a possibility of resubnetting this? Let's find out. How many bits do we have left? Don't forget, we have already borrowed 3 bits. Those 3 are dead. So we have only 5 left. You write out those 5 bits. 1, 2, 3, 4, 5. So can you create another subnet out of this? It just happened that my example is we are borrowing one bit. Sometimes you have to borrow 2. I need to take care of a network of 14. What if we are only dealing with a network of 8 addresses? I will borrow 2 bits because 2 raised to the power 3. In fact, let's remove this guy here, so that we will not be one bit. We are borrowing since we started this example. Okay, let's say we want to take care of a network of 8 IP addresses. If I borrowed 1 bit, put the formula 2 raised to the power 1, it will create 2 subnets. 2 raised to the power 4, 16 addresses per subnet. Is too much. We are going to say having too much. We don't want to. What if we borrow 2 bits? We put the formula 2 raised to the power 2. It will create 4 subnets. We have 2 raised to the power 3, 8 addresses per subnet. Network address and broadcast address inclusive. We'll go ahead and borrow 2 bits. So if we borrow 2 bits, this guy will create 4 subnets for us and 8 addresses per subnet. So that will be subnet 0, subnet 1, subnet 2, subnet 3. So what are the range of the addresses? Guys, don't forget, we are going to have 8 addresses per subnet, and supposing we are starting from 0, that will have been 0 to 7, but we are starting from 96. The address we are breaking now is .96, so that would be 96 to, then you add 7. So this can be cumbersome sometimes. 96 to, let me add 7. If we add 7, and that will give me 103. The next one will be 104 to, then you add 7, 111. The next one will be 112 to, you add 7, 119. The last one will be 122, you add 7, 127. Once this one is 103, you know the next one here will be 104. Once this one is 111, you know this one here will be 112. And don't forget, I said all the numbers of the left can never be odd. The ones on the right can never be even. Don't ever forget that. So this is the network address of subnet 0. Sorry, the range. So the address there is 192.168.1.96 what? Guys, we borrow 2 more bits. That will be /29. I will carry this now and assign to this LAN D. I have allocated this. The broadcast address is .103. The network address is .106. The usable is 197 to 102 on this LAN D. So we have allocated this. Don't forget, we have children left. We have subnet 1 left. We have subnet 2. We have subnet 3. So I will carry subnet 1. Should I allocate it to LAN E? I don't know yet. Do we resubnet it? I don't know. Let's find out. So I will write out, that is 104.104/29. So I will write that one out again and say, okay, don't forget, I'm dealing with only subnet 1 now. I still have subnet 2, subnet 3 of this .96 that we broke. In case I'm not going to use them, we'll document those ones for the future. Dot what? 10 what? I think it's 104, right? One nine two. Oh, I've cleaned something there that I'm not supposed to clean. 192.168.1 what? Is it 104, guys? Please let me. That number, I think it's .104 now /29. I've forgotten that one. No. Let me recalculate again. We're adding 96 to 103. Yes, it's 104. 96 to 104 is 104. So now 104/29. If we give this 104/29 to LAN E, we will be wasting 4 IP addresses because this /29 can give us 8 IP addresses. So can we resubnet it? Let's find out. How many bits do we have left here, guys? We have 3 bits left. We have borrowed all together 5. 1, 2, 3. LAN E is in need of 4 IP addresses, network address and broadcast address inclusive. Can I resubnet this? If I borrow 1 bit, this will create 2 subnets. The remaining bits 2 raised to power 2 for subnets. 4 addresses rather per subnet. So now here again, I'm going to have subnet 0 and subnet 1. Then subnet 0 will be, it's supposed to be 0 to 3. 4 addresses per subnet. But because I'm starting from 104, that will be 104 to 107. The next one will be 108 to 111. This time around, these addresses are /30/30. What makes them /30? We borrow another 1 bit again. I will carry this one here and allocate to LAN E. And that address will be 192.168.1.104/30. I will assign this to LAN E. And guess what? I still have 192.168.1.108/30 that I have not used. I will keep this and document it for the future. Don't forget, we only took subnet 0, allocate it, and then we have been subnetting and resubnetting subnet 1. So we still have subnet 2 of the main one left. We have not touched it. We have subnet 3, which is the last subnet from the beginning. We have not touched it. That is the power of subnetting a subnet to manage the need of the organization. And this is mostly applicable with service provider. If you work with service provider, there's no way around it. You can't, because they will not allow you to waste IP addresses. This is my second example. I hope I have not confused you guys more.